Now what I'm going to do is solve this equation right here, and I know all I need to do is just bring this 1 over side x to the right side, and I'll get that this is equal to negative h bar squared over 2m d square d x squared. I'm going to write it like in this form like this, plus b of x times side of x is equal to times sine of x. And this right here, this here, is my Hamiltonian. This is my Hamiltonian right here. Acting on what? On side of x. And what does it do? Well, it returns side of x back plus a constant. So I can say that if I want to solve this with my time dependent, having the Hamiltonian acting inside, this is going to be equal to side of x times a e to the negative I e t over h bar. But I know that this a, this constant here, right here, is going to be absorbed by side of x. So I can write this equation as the Hamiltonian acting on the side is equal to side of x times e to the negative I e t over h bar. And this right here, what I have right here, this right here, the Hamiltonian acting on side of x goes to e times side of x. This right here is time independent, the time independent Schrodinger equation. So now what I could do is, now that I know this, I can just come and solve. I have all of this right here, and solve for my particle in the box. And I wrote my particle inside the box. See that outside the potential is infinite. The potential inside is equal to 0. My particle is just moving back and forth. So I have that x has to be greater than 0 but less than L, even at the boundaries. And I know what functions can solve this my Hamiltonian, my time independent Hamiltonian. And I know that I have to take the measurement, the calculation at 0 and at L. And I know that a side of 0 is equal to A sine of 0 plus B cosine of 0. Must be equal to 0. Well, I know this here. This is 0. Cosine of 0 is 1. B times 1 equals 0. This implies that is 0. So what I'm going to do is I'm just going to get my time independent, negative h r squared over 2m and second derivative square over d x squared plus bx. Right? What I'm going to do is I'm going to move all of this to this side over here. I'm going to move all of this over here, and it's going to be 2m over h r squared times e. And I'm just going to write it down in this form like that. D squared d x squared plus bx I forgot to write the side right here, times side of x is equal to 2m h bar square times e. But I'm going to call this right here, this part right here in front of e, I'm going to call it k square is equal to 2m e over h bar square. So the way that I'm going to write this down now is like this. D square, the derivative square with respect to dx square plus bx and sine of x. This is equal to k times. So I know that I have my parameters. X has to be greater than 0 but less than L. In order to find the particle. If it's outside, the potential is infinite. We will never be able to find it. So I know already that my function assigned as 0 is going to be a sine of k, constant k times x must be equal to 0. And remember, I'm going to place where x is, I'm going to place L. So I'm going to have a sine, no, what I'm going to do is this. K, what value? K times L gives you 0 when you have sine. Sine of what? K times what gave you? Well, A could be 0 and you're going to get 0, but that's not done here. You can't do that here. What other? How can you get 0? Well, if you multiply n times pi, you're always going to get 0, where n could be 1, 2, 3, 1, 2, 3, and so on. Okay, so now, what is the value of k? Well, k is going to be equal to n pi over L. That's k. So now I know that this is k. I'm going to put it over here, and it's going to be k squared, right? So I'm going to have n squared pi squared over L squared, and all of this is equal to 2m e over h bar squared. So I'm going to solve for e. I need to solve for the e, and this is going to be equal to n squared pi square h bar square over 2m L square. And that is my energy of my particle. And when I put 1, that'll be my lowest energy value. If I put 2, it'll be 4 times. If I put 3, it'll be 9 times. And my function is going to be a, my function is going to be, a sine of what? Of n pi x over L. And this is my eigenfunction. This is my, for the time independent, for function for psi of x. My psi of x is equal to this. And my energy is equal to n squared pi square h bar square over 2m L square. And I'm going to stop here so that I can continue working on the next video, solving the particle in the box. I already have my eigenfunction and my eigenvalue. If you like these videos, please hit like and subscribe. Thank you.